Hi, my name's John Saville, and in this quick video I want to just examine how tokens are used with Azure Active Directory. As I've talked about in previous videos, I can think about, I already have an Active Directory domain services. We talk about on-premises. It doesn't actually have to be on-premises. This could be in virtual machines in Azure IaaS, but essentially I have my traditional Active Directory with my various users in there. And then in Azure, I have an Azure AD instance. And I essentially want to expand my AD into Azure Active Directory. And the way I do that is I have something called Azure AD Connect. This is something that I run on an operating system, a Windows OS instance, typically close to my domain controller, so it could be a VM. And what this enables me to do is synchronization between my Active Directory and my Azure Active Directory. So now the users that I've selected, so I can do an entire domain, I could do different domains in different forests, I could do particular organizational units. So the object I've selected, well, they're now going to have objects in Azure Active Directory. So they're linked, this synchronization behind the scenes is using the same technology as Identity Manager. So MIM, for example, VIM. And the benefit here is I get a number of features with Azure Active Directory. Now this varies based on the SKU, but one of the biggest ones I get is great insight into the activity, security. I can do MFA, and I can think about Azure Active Directory as this federation broker. It has all these different federations with nearly sort of 3,000 different cloud services today. And they can include custom ones that I add. I can have my own applications. Once I register an application with Azure Active Directory instance, then it can use that for its authentication. But the question comes up, okay, so I have this user. How do they actually authenticate to Azure Active Directory? And there's actually two ways I can authenticate. The first is really a cloud-based authentication. So I'm sending my kind of username and my password over an encrypted channel to Azure Active Directory. Now, option one is as part of this Azure AD Connect, I can also send a hash of the password hash that's stored in that Active Directory. It's not the original MD4 hash. It goes to an MD4, to an MD5, a whole bunch of sorts, and spits out another MD4. And that's what it replicates and stores in here. So I could not take this hash, even if it was compromised somehow, I could not reverse that and find out this hash. And actually, no matter which authentication option I use, as I talk about the others, it's always recommended you send the hash to Azure Active Directory. So it gives you things like leaked credentials. There's things that happen in Azure Active Directory to scan the dark web to find out, hey, well look, I found this credential out for sale or whatever on the dark web. If it has the hash, it can compare that credential it finds to the hash and say, well, yeah, look, it's the same password. It can show you that in a report. I could do things with conditional access to make them go and change their password after an MFA. So no matter what you do, it's advisable to have the hash in Azure Active Directory. It can also be a good break the glass. I could switch to that if my other method went wrong. And some services, things like Azure SQL Database, Azure Active Directory domain services require the hash to be there. So it always a good idea to have that hash in Azure Active Directory. But if I'm doing the cloud authentication, so I think about, hey, this is cloud auth. The first method to validate the password is, well, if the hash is here, it can just authenticate against that hash, and it continues. The second way I could validate the password is, well, there's something called pass-through authentication. And with pass-through authentication, when I send in that request, there's actually kind of a pass-through authentication queue. It uses service bus behind the scenes. I have a bunch of kind of pass-through authentication agents. I can have multiple of these. They register with the service. They establish an outbound 443 connection, so I'm not having to open up ports to the internet. It establishes outbound for each entry, so I request an authentication. It writes it for each agent, encrypted with a key specific to each agent. One of them grabs it, goes and talks to AD, says, yep, that's good, passes back, and they get authenticated. So I have two options. You can use the hash for the password validation, or you can use password authentication. I still get seamless sign-on. I can turn that on if I'm on a corporate join machine on a corporate network. I still get a seamless sign-on experience. Now what's happening in this is, if I think about, there's different components here. I have the client, I have Azure Active Directory, and I have the service I'm actually trying to get to. This could be Exchange Online, SharePoint Online, it could be again just some other app that I've registered with my Azure Active Directory tenant, so it's allowed to talk to Azure AD. I can use the Microsoft Authentication libraries to go and do that, all the work for me. Now this is simplified. Really in Azure Active Directory there's different parts. There's an authentication endpoint, there's a token endpoint. I'm going to kind of combine all these and simplify it down. But really we're using sort of OpenID Connect, which is based on OAuth 2. So as the client, I say I want to get to this service. And we could say, for example, this service is something based on Exchange. Exchange is going to say, well, I've got no token, I don't know what to do. It's going to redirect me to Azure Active Directory. Azure Active Directory has to find out where I'm from. This is the first time. There's no cookie to help it know where I'm from or any. I'm not using a hint as part of that service. It has to do a realm discovery to find out which tenant I'm actually from. And again, there's ways where I don't have to type in my username for this. As part of the URL, I can send that. There are cookies if it's based on the web browser. From here, I would put in my username and my password, which it would validate using either the hash or password authentication. But essentially it would go through that authorization endpoint, I'd get an identity token, I'd then send that to the token endpoint, and what it would send me back then is two things. I'm going to get an access token for that service, and I'm going to get a refresh token. Now the reason for this is this access token is good for this service, but it's very short-lived, let's say an hour. So you say, great, I can now use that access token to go and talk to Exchange. An hour's gone by. It now stops working. And you're thinking, well, I don't remember having to prompt to reauth again. You don't, because this refresh token, this is, let's say, 30 days. So at this point, the good news is, behind the scenes and automatically, it will send the refresh token back to Azure Active Directory. And providing nothing has happened to invalidate that refresh token, I've changed my password. I've issued a logout of all devices. I can use PowerShell to do that as well. Assuming that has not happened, it's just going to send me back, hey, an updated access token and an updated refresh token. So the refresh token is 30 days, it's a sliding window, up to 90 days kind of maximum. So then I would just carry on my communication with my updated access token. But now you say, well, now I want to talk to SharePoint. From the same client. So if it's a web browser, the same web browser. And this refresh token is going to last for the duration of that client is running, that session in that browser. So now I want to talk to a new service. So now, really the same process. I'm going to, once again, send my refresh token, essentially to Azure Active Directory, now saying, hey, I want to talk to this service. It's going to send me back kind of an access token 2 for that specific service, and again an updated refresh token. And I can now send access token 2 so I can talk to SharePoint. And SharePoint actually does some different stuff. SharePoint actually then creates a session token which it sends me back, and I use that session token for the ongoing communication. And that just enables me, in case the access token ran out when I'm editing a document, I don't get stuck. But that's kind of the important point here. The way the tokens work is, yes, the first time I have to authenticate, but then for subsequent services I access, I don't get prompted again, because this refresh token just gets used against the Azure AD token endpoint to give me new access tokens, and if they run out after an hour, it just automatically will go and get me another one. So that's what's behind the scenes happening with the tokens. Now the only thing to consider here, generally, password hash first. When I think about what one I pick, password hash, if I think about maybe a downside with password hash, and this is minimal, especially when you look at how the tokens work, well yes, the password hash is stored in Azure Active Directory, but we kind of want that anyway. When I think about those security benefits I get with protection from breach replay, hey, a leaked credential, when I get those reports stopping you using silly passwords. But maybe I really do not want that password stored. And additionally, if I use password hash, if the account is locked here, if I have restricted logon hours, if the password is expired, it will still let me authenticate. Whereas if I'm using partial authentication, it would respect those things. So there is a slight difference. I'm not really worried about how the password's changed. There's kind of an urgent replication. Within 2 minutes it's going to be there. But that would be a difference. Partial authentication, because it's checking against my DC as it's doing, but only, and that's the important point here, only at the initial authentication. For the rest of the time, it doesn't use that partial authentication anymore. It's only for the initial authentication. It's using the password hash or partial authentication of that session. Once it's done it once, well, now I'm just using my refresh token. None of this matters anymore. So that's why it can kind of be an important factor. It's like, well, the account's locked, the password's expired. Unless I'm closing my session, I'm going to carry on accessing stuff anyway. But with partial authentication, this is modern authentication. This is modern auth. The idea that, hey, I as an endpoint, I go and talk to Azure AD, I go and get these tokens, and then I present it to the service. Partial authentication doesn't work with legacy authentication. And so legacy authentication, we draw this in kind of a sad, so bring back legacy auth, just so you understand kind of the difference. We do a sad face. If I have, again, I think about my client, I think about the service, and I think about Azure AD. Remember, for modern auth, I go and talk to Azure AD, I get the token, I give it to the service. Legacy authentication didn't work that way. With legacy, the client would talk to the service would then kind of proxy the request and send it to Azure AD. It would get the response back, and then it would give me my service. Well, this doesn't work with partial authentication. And when we think about legacy, we're thinking pre-Office 2013, those types of clients. This shouldn't hopefully be a consideration today, but just bear in mind partial authentication would potentially struggle if I'm using legacy auth or anything. So that's option one, cloud authentication. That's how kind of the tokens work, no matter which one I do. The other option, it's really kind of the same sort of picture again. I still have the same AD on premises. I still have the same Azure Active Directory up here. I still have the same AAD Connect replicating stuff. So I'm still populating it with the users into the cloud. Nothing has changed. I can still optionally send kind of the hash of the hash. So I can do those security things that break the glass if something else failed. Still has all those federations. Nothing has changed there at all. But now I want to use federated authentication instead. So now as the user, I think about, hey, I want to authenticate. I go and talk to this, and what's happening is I have some kind of federated service. This could be ADFS, could be something else. It's going to kind of redirect me back. It's going to say, well, go and talk to the federated service. That's where I'll kind of give it my username, password. I get single sign-on if I'm on that corporate joined on corporate network machine. But again, I get the same experience with password hash and PTA if I have seamless sign-on configured in my organization, which is super easy to do. It would go and do the check to AD. It would go and get that kind of token based in SAML. It would kind of give that back to me, at which point I would present that to Azure AD, and it would then go and create a token, which it would give back. But essentially, authentication actually happened against my federated service. So this is my federated authentication. So I never sent my username and password to Azure Active Directory at all. I just get kind of redirected to talk to my federated server. It gives me a SAML token, which because of the federation between my federation service here and Azure AD will accept, and then give me my Azure Active Directory tokens. This is really not pushed today. I have to maintain this whole set of infrastructure, multiple ADFS servers, or whatever you use, multiple proxies on the front end. I have to open up firewall exceptions to this. Some of the benefits, I can use third-party MFA providers. I can do certificate-based authentication. And in the past, it was the single sign-on. But again, we have that same experience now with the password hash and password authentication. There's a lot to maintain here. And people will say, well, hey, I can do policies here. True, but let's look at the flow. So again, on this flow, one of the things I didn't kind of stress is at this point, I can apply policy. So at all of these different points, I can apply various policies. I can do conditional access, I can check things, I can make those things happen. So if we take this same picture, but now think about the federated view. So the federated view of the world, we're going to add in ADFS. It's like, well, I want to use ADFS, I want to use ADFS policies before I access anything. So let's consider what that flow looks like. So I still have the client. Now I have my federated services, again, could be ADFS. I have my Azure AD, and I have the actual service I'm trying to access. So how does the flow change? Because hey, I'm using federation now. Well, so my client tries to access the service. Again, I'm going to get pushed back to Azure AD that kind of does that realm discovery. When it does the realm discovery, it says, well, actually, you're federated. So it's going to kind of redirect me back to my federated services, at which point I'll authenticate against that. It's going to give me a token and send that back to me. And then I take that token and I give it to Azure Active Directory. And it says, great, okay, it's got claims about me. And what does it give me back? It gives me back an access token and a refresh token. Should look familiar. At which point, I go and give the access token to the service I'm trying to access. After an hour when it runs out, I'll use the refresh token to talk back to get a new access token, I'll carry on. When I try and access my second service, so let's just say, again, we could say it's SharePoint. What do? Well, I go and give my refresh token to Azure AD, and it gives me back a second access token and an updated refresh token, and I go and talk to the second service. I did not go back through the federated server. I didn't have to authenticate again. So in terms of applying policies, yes, at this point, I could apply policies on my federation server, but only for the authentication for that first time. For all the subsequent use for the lifetime of this refresh token, I need to do the policies in Azure AD. And that's kind of a really important point to understand. So often people say, hey, I want to use federation because I want to get all the policies to come through me every time they access a service. It does not work that way. Because of the way the token works, and that refresh token, once I've authenticated, I'm not talking to that anymore. It's all now just talking to Azure AD via that refresh token. So that was really sort of my goal, to go through those different methods of authentication. So you think about cloud authentication, and it can validate the password via the hash, or it can use pass-through authentication. Again, no firewall ports to open, fairly minimal infrastructure, very simple to set up, outbound 443. Or I can use federated, I have to maintain all this infrastructure, open up ports, and ultimately it's still not being used for most of the policy. I still have to do the policy in Azure Active Directory because that's what's being used to access the services. So when I think about priorities, when I pick these things, my guidance, I try and use password hash first if I can. If there's really some compelling reason I can't use the password hash, I must have restricted hours. If the account's locked, I must lock out that account. But again, you have to remember, well, if I invalidate the refresh token, because I can still go and get the stuff, regardless of what I do. If I can't do password authentication, maybe I have some requirement, maybe a third-party MFA, but again, that wouldn't integrate with things like privileged identity management escalation today, then federated. But really, this is a huge amount to maintain. It used to be useful when I used this to federate with other services, but most of those federations you're going to move and actually implement via Azure AD. So I don't have to maintain that going forwards. So I hope that was useful. That was just kind of a quick summary. I'm really just trying to understand how the tokens work. This is simplified. Again, there's kind of an authorization endpoint, and then there's a token endpoint. There's an identity token, which is what AD Connect does. But it's not really that important to understand. The key point to understand is these access tokens and the refresh tokens. Very small lifetime, but doesn't matter because the refresh token will automatically get used to get new ones so I can carry on accessing the service. Hope this was useful to you. Thanks very much.